let's think about what causes vertical asymptotes. So this is a graph of y equals tangent x, and you see that there's a vertical asymptote at every at pi over 2 plus integer multiples of pi. So pi over 2, 3 pi over 2, 5 pi over 2, and so on. Let's answer that question by starting with a simpler model. So one of the simplest equations that you can write that has a vertical asymptote is the family 1 over x. And here I've got a right-shifted 1 over x. So we've got a vertical asymptote at x equals 1. So you're probably thinking, well, so if I were to ask you, where is the vertical asymptote coming from, you'd probably have a pretty good guess about that. If you plug in x equals 1 to this equation, you'll get 1 minus 1 is 0 in the denominator. So your initial guess might be whenever there's a 0 in the denominator, that's what causes an asymptote. But let's think about this equation, y equals x minus 1 divided by x minus 1. So think about what the outputs of this function are going to look like. Actually, why don't you go ahead and try and sketch the graph yourself. Think about plugging in different values and plot those values and try and connect them. I'm going to pause the video right now. Okay, hopefully you said that this looks like the line y equals 1. And that's true at every single x value you plug in except x equals 1. Because if you plug in x equals 1, then you get 0 over 0, which we've said before is an indeterminate form. And so you have a hole right here at 1. So this is just a straight line with a hole in it. So this might lead you to a new conjecture. Maybe you're thinking, whenever I have a non-zero value divided by 0, that'll be an asymptote. Whenever I have 0 divided by 0, that will be a hole. For the functions that you're going to be dealing with right now, that's probably a good rule of thumb to use. But you should realize that we haven't really explained anything. All we've really done is draw some examples and make some observations and say it seems like whenever we have examples that look like this, you get this type of discontinuity. But we haven't really explained why yet. So the why is going to come in the next video, and it's going to have to do with limits. You might remember we talked about limits at the very beginning of the year. If you ask kind of visually or graphically, what is really the difference between a hole and an asymptote? It doesn't have anything to do with what's happening right at the value where the discontinuity is. Here, when x equals 1, the output's not defined. And here, when x equals 1, it's the same thing. The value's not defined. The difference between asymptotes and holes has to do with what happens when you get very, very, very close to the discontinuity. So as you look at x values, they get closer and closer and closer. What's happening to the y values? And in the case of a hole, the y values are getting closer and closer to the hole, whereas for an asymptote, the y values are increasing to negative infinity or increasing to positive infinity or decreasing to negative infinity. So again, the difference between an asymptote and a hole doesn't have to do with the x value where you're plugging it in and you're getting the 0. Instead, it has to do with what happens as you get closer and closer to that x value. But for right now, until Thursday, this is probably a perfectly adequate way of thinking about it. So using what we just talked about, first tell me what is the definition of tangent? Like how do you rewrite it in terms of sine and cosine? And then tell me, so why exactly do you find vertical asymptotes at pi over 2 and 3 pi over 2 and so on?